So we've been talking about the muscular system and how these slabs of magical meat spanning across the joint surfaces will produce movement in the anterior, posterior, medial, lateral plane, leaving movements. These movements are referred to as flexion, extension, abduction, adduction, and it was important to remember for any given joint we're talking about what those terms flexion, extension, abduction, adduction mean. So if we're standing in an anatomical position, we're considered fully extended, and movement in an anterior position is considered flexion. And the major qualifier of that is when we're talking about the knee and ankle, we're talking about movement in the posterior plane is flexion. And the other major movements will be in the medial lateral plane, right? That'll be abduction, that is moving away from the body, and adduction, bringing your limbs back in toward the body. And so muscle only works by exerting a pulling force, right? When it contracts, it's creating a pulling force that's going to pull on those bones, move them closer together, right? It pulls, it doesn't push, right? So you need muscles on each side of that joint to create these opposing movements. So we'll be going over some of these major muscle actions using this cool mobile app from visiblebody.com. And what I'd like you to pay attention to is how the muscle is spanning that joint, anterior, posterior, medial, lateral, and how that relates to the action at that joint. So the first movement we'll talk about is action at the shoulder, right? Moving that glenohumeral joint, the humerus around the scapula right here. Right, and this is moving the shoulder in an anterior position for that flexion movement. Your anterior delts are doing a major part of this. Your upper pecs are also causing this shoulder extension. Your biceps brachii is also causing that movement, right? Meanwhile, the muscles that are spanning the posterior surface of that joint are causing these extension movement, right? Your posterior delts, your triceps brachii, right, are causing this movement in the posterior plane right there. That is the shoulder extension. Also around the shoulder joint, those muscles spanning the surface are causing abduction, abduction, whereas muscles on the medial surface will be causing the movement of adduction, DD, adduction. Looking at action at the elbow, we'll see those muscles that are spanning the anterior surface of that joint, such as the biceps brachii, your brachialis, your brachioradialis, are all spanning the anterior surface and they're causing flexion. Meanwhile, on the back of the arm, you have the muscles, mainly the triceps brachii, that are causing extension, right? So those muscles are spanning the posterior surface of the elbow joint. Also, just distal to the elbow joint, you'll have those rotational movements around the radial ulnar joint, pronation and supination, right? Moving distally, the next action we'll talk about is at the wrist. These are muscles that span the anterior surface of the forearm. They originate on the medial epicondyle of the forearm. And then on the other side of the wrist, you have those muscles that are spanning the posterior side of the wrist. Most of these are originating from the lateral epicondyle, and again spanning mostly the posterior surface, causing that wrist extension. Down to the lower limbs for action at the hip joint. We'll have our hip flexors spanning the anterior surface of the knee, causing that anterior movement of the thigh, right? So the major muscles are going to be your psoas major and your iliacus, as well as the rectus femoris, causing that anterior movement. And the muscle spanning the posterior side of the hip joint, causing that posterior extension movement, will be the hamstrings, your biceps femoris, and your semitendinous, as well as the underlying semimembranous, and of course the gluteus maximus, causing those hip extension movements. And then you have the muscle spanning the medial side of that hip joint there, bringing the thigh in toward the body, your adductors. We also have the tensor fasciae latae spanning the lateral side, causing that hip abduction movement. Moving distally to the knee joint, we have muscles on the back of the leg, the posterior side, causing these knee flexion movements, including your hamstrings, your biceps femoris, your semitendinous, as well as a little bit of your gastrocnemius there. So this is a switch over. All these muscles are on the posterior side, causing these flexion movements when we get down to the knee, as well as when we get down to the ankle. These flexion movements, called plantar flexion, are caused by the gastrocnemius and the soleus on the posterior surface. Going back to the knee, we're going to see that the muscles that are causing extension of the knee are on the anterior surface, spanning the anterior surface of the knee, inserted into the patella tendon, such as your rectus femoris and your other quads. And for the movement referred to as dorsiflexion, which is really an extension movement, if you think about it, those muscles spanning the anterior surface of the knee, such as your tibulus anterior, as well as your extensor digitorum longus, they're causing that dorsiflexion movement. So that's it for the limbs. Next, let's look a little upward at the vertebral column, movement of the vertebral column, spinal flexion caused by those abdominal muscles. The external obliques is a major spinal flexor. Spinal flexor, anterior movement, and spinal extension. Those erector spinae muscles on the back there causing that backward movement of the spine. So the spinal flexors and extensors can be moved unilaterally to create that lateral flexion of the spine as well. Lateral flexion of the spine. And last we have the movement at the neck, the cervical spine, as well as the atlo-occipital joint, flexion caused by the sternocleidomastoid, extension caused by the trapezius on the posterior side. Alright, so that's it. And you'll notice that all those muscles, right, they had a muscle maybe for talking about flexion on the anterior side. They'd have an opposing muscle on the other side, on the posterior side, kind of opposing that movement right there, right? Any of the muscles we talked about. And so the terminology used to describe the muscles that are producing these opposing movements are the terms applied to what are the functional roles of these muscles. That is, agonist, antagonist, and synergist. And so the contraction of the sternocleidomastoid muscle is producing flexion of the neck and would be considered the agonist of that action. While the sternocleidomastoid is contracting and causing the flexion of the neck right there on the other side of the joint, right, on the posterior side is your upper trapezius, which is being stretched in that same movement. That muscle there would be the antagonist for flexion of the neck. Another example is lateral flexion of the neck to the left, where contraction of the left sternocleidomastoid, the agonist, produces that lateral flexion to the left, whereas the right sternocleidomastoid muscle, the antagonist, is being stretched. For both of these movements, flexion and lateral flexion, will flip those functional roles by making the action extension of the neck, where the trapezius becomes the agonist, contraction causing extension or hyperextension, while the sternocleidomastoid stretches. Switch that lateral flexion to the right, and those roles were reversed as well. Then the other functional role we talked about was that of a synergist, muscles that help the agonist in some way. Right? We also included in this muscles having the roles of being a fixator, such as those muscles that are stabilizing the scapula. We also went over the relationship between how a particular muscle works and its shape and the arrangements of fascicles, these visible lines that we see in the muscles here. So on the left, we have the hamstrings, right, looking at the biceps femoris and your semitendinous muscle, both of these muscles having a parallel arrangement of fascicles. The fascicles running from tendon to tendon, all parallel with each other. On the right, we're looking at the rectus femoris of the quads, which have a bipinnate arrangement. The fascicles here are inserted obliquely into the tendon, which runs along the long axis of the muscle. This allows more muscle fascicle and fibers to fit on the same area, And the more fibers contracting, the stronger the muscle. So while the pennate parallel muscles offer a greater range of motion because of the length of the fascicles, the pennate muscle is much stronger because there's a greater number of those fascicles and hence fibers. Then muscles such as the pectoralis major, shown here, have a broad-based area where the fascicles originate and then converge onto a single insertion point. These are called converging muscles, and they offer a great versatility of movement because different sections of the muscle can act independently of each other and even offer opposing movements at that same joint. So when we are talking about those fascicles that we can see visibly, these are the bundles of muscle fibers. This is a bundle of those very long skeletal muscle cells. This brings us to the last review topic here, which is the organization of skeletal muscle tissue. So we have this tube within a tube within a tube organization, organized by these layers of connective tissue. The smallest tubes are the muscle fibers, and they are covered by the endomysium layer. A bundle of those muscle fibers covered by the perimysium makes up a fascicle. And then the muscle itself is made up of groups of these fascicles, and the whole muscle is covered by the epimysium layer. So these connective tissues not only organize the tissue, but have other important roles. So be sure to review those and check back with me if you're not clear. Okay, that's it for the recap. Next time we're going to talk about the microanatomy of muscle tissue, the specialized organelles that allow muscle cells to contract, give it its unique properties. Okay, so we'll see you next time. Have a good weekend.